Okay, cool. I think I'm gonna start. So hey everybody, my name is Alexey. I'm Android engineer at Lyft. For some of you who doesn't know, Lyft is one of the biggest ride-sharing company in US. So if you have ever seen cars with glowing pink mustaches on the front, these are the cars you can request through our app. Today I'm going to talk about applying principles of domain-driven design as a way to organize and talk about business logic of your app. Since architecture is quite boring, I'll start my presentation with a funny story. So this is actually what happened on one of our Android interviews. So I started my interview with a typical opener. What was your previous application architecture? And then the guy started telling me, oh, I'm using retrofit for network, RX Java for async operations, currently switching from Dagger 1 to Dagger 2, recently migrated from Picasso to Glide. And then I asked, what about the logic? And the answer was, oh yeah, I store my retrofit classes in a folder called models. So while this particular case is very extreme, there's still a big fundamental problem in the way many Android engineers think about their app architecture. And the way I see it, for many people, app architecture become some kind of art of combining various frameworks and writing less lines of code. Unfortunately, in my opinion, this mindset doesn't work well for big project. So today I will try to share our vision for application architecture, where app logic takes the central place and everything else, including Android framework, we consider some details. To make my talk less theoretical, I decided to structure it as an evolving implementation of specific feature. So I will start from a very straightforward dirty implementation. We'll highlight what is wrong with it, and while we improving it, I will reveal basic concepts of domain-driven design. So the feature we're gonna implement will be displaying of pickup and drop-off locations, and every time the user trying to refresh them, we have to use cache if the last request was less than 30 seconds ago. So back in the day, Lyft API looked something like this. So it was a single app state object that was including information about the user, ride, and a lot of other details. And for our particular use case, we're only interested in ride and its stops that include information about pickup and drop-off. So that all sounds easy. Let's apply foolproof architecture method and put everything inside the view. So inside the view, we're gonna use Lyft API that give us the app state, and for caching, we will use Android shared preferences and JSON to serialize the latest state of the ride. So the code will look something like this. So first we check if shared preferences has cache data. If it doesn't, we make a call to Lyft API and put right to the cache. And for getting the pickup and drop-off, we will have some filtering logic that iterate through the stops and find the stop that is pickup and the stop that is drop-off. So while this is a working code, it will likely have problems when it will come, then the time will come to introduce more features. So first, by its nature, API doesn't usually fit UI needs. So we had to introduce some methods within our view that extract the pickup and drop-off from the view. And they are not tested at all. Second problem is that logic around fetching and caching lives inside the view, and if we will ever need to reuse it somewhere else, we have to duplicate that code. And the third problem, since now everything concentrated within a single class, it likely will become some kind of God class whenever the code base will become bigger. And obviously, nothing is tested at the moment. So let's try to address the first problem. So getting back to the Ride API, we have the part that describes the entire state of the app, which is an app state data transfer object. And UI doesn't really need to know about it. So it's good if we will try to avoid exposing this information to the view we're working on. Another problem, as I mentioned, that all the right filtering logic is currently living inside the view, so we can't easily test it. So to address that, let's introduce a ride model that will contain only data relevant for the ride and will encapsulate all the filtering logic inside it. And the great part about the model is that now we can finally write a pure Java unit test for this filtering logic. And as maybe somebody noticed that we have some obvious duplication of the code here, so we can apply some simple refactoring by extracting this method. And the beauty is that since we have a test for those methods, we can guarantee that the code will still work and we don't even need to reinstall the app on our phone and check it with the UI. So going forward, we will call models like ride the main object. So let's give a proper definition to them. So the main object are entities that are independent from UI or the storage, which define a vocabulary to describe use cases within our app. And since we no longer use data transfer object provided by our API, we need to introduce some kind of mapping between data transfer objects and our domain. And we will call these classes object mappers. So object mappers will encapsulate details about transformation of data transfer object to domain and vice versa. In our practice, we usually use some simple classes that exposes some static methods, and same as the model, they can be easily unit tested. Well, some of you may be wondering why I can't use data transfer object instead of domain object, why introduce all those complexities. And there are a couple of reasons for that. So first, data transfer objects are optimized for transferring data efficiently, not for your app logic. They can easily get changed on the API. Your API could always get changed at any moment, and that will, if you're using them, that will impact your entire UI. Also, in the case of Lyft, we actually code generate our data transfer object from the Swagger schema. So we technically have zero control over those classes, so that's why we can never introduce any logic within our data transfer layer. And finally, your infrastructure could change at any moment. You could switch from JSON to protocol buffers or just switch from one serialization library to another. So let's go back to our to-do list. Now we finished the first item, and let's try to move logic outside the view and make it reusable. So this is the piece of fetching the write from API and caching it. So now we move it to a new class that we will call write service. And as you can see, the write service hides the fact, hides the usage of data transfer object, and now exposes to our UI layer only the model we define. But still, the implementation is a little nasty and has a lot of logic inside it. And technically, it's still a God class. And the problem with God classes is that they get bigger, and it's almost impossible to test them. So if we will look again, the most complicated part that takes a lot of screen space is the logic devoted to restore value from cache and put it back to cache. So let's try to delegate that function to some other guy, which we will call cache. So in this case, our write service will look much smaller. We now have some nice cache API. And service no longer actually doing any logic, it's just orchestrating between two dependencies, which are cache and Lyft API. And the good part that now we can easily write unit test for this behavior. So in this particular sample, I verify that if there is a value in cache, Lyft API should never be called. So we will be calling such services application services, and the definition for application service will be a service that defines a boundary between your business logic and UI. It orchestrates all dependencies and orchestrates all dependencies behind it. And the key word here is boundary and orchestration. So let's get back to caching logic. And as I said, we will delegate it to a separate class called cache. So here is the implementation of some generic cache class that is based on Android shared preferences and JSON. And again, we can easily write unit tests specifically for this storage logic. So services like cache, we will be calling infrastructure services. And purpose of infrastructure services is to provide some specific essential function to perform a business operation. In our case, it's caching and request and write from the server. If we will get back to the test, I cheated a little bit here, and I'm using Roboelectric to fake Android environment. And ideally, we want to avoid that because setting up Roboelectric or any other way to fake the Android environment will be tricky and quite fragile. And at the same time, while Roboelectric is much faster than pure Android tests that run on the device, they still require more time to execute. So technically, we can apply the same approach we took with application service and find the hard dependency that we better delegate and put those details out of our cache implementation. So in this case, it's usage of Android shared preferences and JSON serializer. So now we can introduce two new infrastructure services. One of them will be data serializer, and another is key value storage. So our unit test will now be much more cleaner, since now we're working with just pure Java objects, and we no longer have to care about the complexities related to Roboelectric or any other way to fake the Android environment. So let's look again at our to-do list. Now we resolved issues related to difference of API and UI needs. We made our logic reusable. delegated individual pieces of it to separate classes, and everything is tested. So what is the big picture? So now our view talks to our application services only through our domain language defined by our domain objects. And then application service orchestrates dependencies that are the variety of infrastructure services that also could have a more detailed structure, like a cache that actually, in fact, works with abstraction of data serializer and key value storage. So this brings us to some basic principles of clean architecture defined by famous book writer Robert Martin, also known as Uncle Bob. Who knows Uncle Bob? Oh, that's good. A lot of people. So yeah, clean architecture should be independent from UI. That means that technically same principles could be applied while you working on iOS app, desktop app, web app, or even console app. And this getting back to the point that I raised in the beginning of my presentation, that the focus shouldn't be on combining and like all the frameworks that get released by Android. The focus should be on the logic of your app, and all those frameworks should be isolated from the logic of your app and consider just details that should be hidden. And definitely one of the primary principles is that your architecture should be testable. I guess some of you are familiar with testing pyramid. So usually you have unit tests, UI tests, and some integration tests. But I personally like this version of this pyramid because it doesn't matter how advanced UI testing tools or integration testing, it will always take a lot of time to execute. So when you make a change, you probably won't run all those tests. And the only thing that you will run is your unit tests. And ideally, your unit tests should take just a few seconds to execute. That's why I pointed out that it's very important to avoid even things like roboelectric, because those tools, they still get too much time to execute. Because if your unit test suite will take 1 or 2 minutes to execute, many people will stop executing every time they make a change. And that's why soon all the refactorings won't be safe anymore, since people will start just doing changes, don't verify that the entire test suite still work, and that's how the things get broken. The biggest advantage of using domain-driven design comes when you actually need to evolve your business logic and new features get introduced. So let's showcase it by a new example. So this time we need to introduce waypoints in addition to pickup and drop-off. The requirements for this feature are that waypoints need to be shown as gray dots on the map. And the second requirement is more interesting, and it's when a new waypoint is added, the previous drop-off should become a waypoint, while new waypoint will become a new destination. So this is our current ride model. We can easily introduce some filtering for displaying waypoints on the map. And the more interesting part is adding a new waypoint. So here we have some, let's say, complicated logic. I mean, in real life, it could be much more complicated. So every time you add a waypoint, you make a copy of your pickup and previous waypoints, convert your destination to waypoint and add your new waypoint as destination. And the good part that all of it could be trivially covered by unit test, and basically entire development of this feature you could do mostly without even running UI even single time. So everything could be done within the logic layer, test it, and when all this done, you can spend a little time to hook this to the UI. And that's actually save lots of time during development, because to build Lyft project at the moment, it almost takes 2 minutes on some average machine. But not only features are changing over time. Sometimes even your often your infrastructure changes too. And one of the infrastructure change examples could be migrating from version API 1 to version API 2. So as you remember, the old Lyft API was based on some sync object that include all information. And then eventually we reached the maximum with this approach, because since Lyft was sending a lot of data, and while we was keep pulling for this single object, it didn't make sense and significantly were polluting the data channel. So after that, we split all resources to separate endpoints. So now to fetch the write, you have to call a separate endpoint. And in addition to that, our API team also changed the camel case to snake case that was exposed publicly through the public API. And this is if I were using data transfer object, I will be in trouble, since my entire code base have to get switched to new API, and also the camel and snake casing will be an issue. But in addition to that, API team said, we want to release it, but we're afraid to release it to 100% of the users. So it will be nice if there will be some sort of kill switch for this migration. And that's another problem we have to deal with. So if we will look back at the implementation of write service, you can see that for cache, we were using previous data transfer object from old API. And this is no longer possible, since we have two different data transfer objects, from old API and from new API. And we could easily solve it by introducing a cache data transfer object that will be independent from API and will be only relevant to our domain model that we defined for the write. In addition to that, we introduced some branching logic, depending what if experiment is on or off. And I think I didn't show you this part. Okay. So yeah, this is the write cache data transfer object, the branching logic for different APIs. And again, it all can be easily tested. So to summarize the advantages of domain-driven design, first, it makes it easy to evolve your code base. Then it gives you a better control over complexity of business logic. It also enables you for faster development through testing, since you no longer need to compile your entire app. You can just compile the logic module or modules right now, like our logic actually distributed between different micro modules. run the test suite as a way to verify that thing works. And only at final stage, you link it with the UI and verify that UI work. And another thing that it brought to our team was as an essential language to communicate about like any business logic related issue. Because before we adopted domain-driven design, we didn't have a language to express how things should be done. And people were usually saying, oh, that should be live in business logic layer. And everybody understand it in their own way. And there was a lot of confusion, and only on the review step, when people implemented certain features, we were arguing about, no, that shouldn't be done like this. And basically adopting domain-driven design language make everybody understand each other better when we're talking about the app logic. So this is it for today. This is our Android team. We're definitely looking for some talented Android engineers to join. And I'll be happy to answer your questions.